So as Grant mentioned, my name is Josh Cincinnati, and no, I didn't change my name to Josh Cincinnati. It started out that way, I swear. I'm so glad to see so many of you here manage to peel some of you off from what was sure to be a riveting vice presidential debate tonight. So I'm glad that you prioritized this over that, unbelievably. But yeah, I'm here to talk a little bit about building with blockchains and BlockCypher. So today I'm going to kind of go over a wide variety of things, namely a little bit of background about BlockCypher, what we do, what we've done in the blockchain space, where we plan to go with Ethereum, give you a little bit of an overview about our current Ethereum support, have a demo time, which unfortunately won't be as demo-tacular as a result of a certain DOS going on right now, which has affected us a little bit, but we can talk about that at length perhaps. And then the other component of this will be a little bit of question and answer, not just about BlockCypher, but just generally about our plans with Ethereum and honestly, even for me, I'm still sort of new to the community, and I'd love to get feedback from those of you in the developer community for the kinds of services that could make BlockCypher support of Ethereum even better. So with that, and if you have any questions at any time, there will be the Q&A at the end, but feel free to jump in whenever. I love answering questions. So first, a little bit background. So background on me, I first got obsessed with Bitcoin probably in like 2012. In 2010, I heard about it and just thought it was crypto drug money and let it lie. But after I had a couple friends sort of walk me through how amazing it could be, I got hooked. And similarly with Ethereum, I actually had a friend that I had explained Bitcoin to, who then 2 years later explained to me how Ethereum works. And it's like one of these student becomes the master moments for me, which is pretty cool. On the BlockCypher side of the equation, we've been around since 2014, providing a wide variety of APIs that support a number of Bitcoin-based blockchains and alts. So Bitcoin, Litecoin, Dogecoin, Bitcoin testnet, our own internal testnet that's Bitcoin compatible, and we've just announced our Ethereum support. So these are some of the customers that use us, predominantly in the Bitcoin space, but some of them are also starting to pursue Ethereum. So the question is, what do we actually provide, and what do they use us for? So we're an API service, and one demonstration of that is our own accounts dashboard uses our API to, in this case, generate HD wallet addresses from Bitcoin. And it was just a few lines hooked up to our Go SDK that enables that to happen. No private key required, which is a nice feature of HD wallets. So we just introduced our Ethereum APIs, and we have a lot of the sort of same things that you'd expect from any blockchain service provider. So looking at the blockchain itself, querying it, addresses, transactions, generating your own transactions. Most importantly for Ethereum, our contract API, which is all about making it easier to interact with contracts. So to give you an idea of what this actually looks like, this is just a curl to get information about Ethereum main chain. So you'll see things like the name of the chain, the height, hash of the last mined block, the latest URL that you can get more information about the block, gas prices, high, middle, and low, based off of how fast it'll confirm into the Ethereum blockchain, peer count, stuff of that nature. Now what's really cool about our particular approach is that we are somewhat blockchain agnostic, and if you want to switch from using Ethereum to something else like Bitcoin, you can do it, and notice that the API, the call response, is very, very, very similar. And if you feel really crazy, you can do some Doge too. So that makes this really flexible for people that are approaching blockchain development that want an API that supports many blockchains. Obviously, on the Ethereum side of the question, the responses differ a bit from what you'd expect from our Bitcoin-derived APIs. So there's no gas in Bitcoin, there's gas in Ethereum, so we have gas price in Ethereum and not in Bitcoin. But otherwise, the responses themselves and even the sort of the resources of the API look very familiar across even Ethereum and Bitcoin. But let's do something a little bit more fun. So if you publish your smart contract through Ethereum, we'll actually give you a full response that includes the Solidity code, the ABI, binary, all right there in a JSON response. It's kind of hard to see here, but obviously with any JSON linter, you could take that, export that, and put it into something more readable. So there's a ton that we offer, and we're going to be offering a lot more soon. But I think maybe the coolest thing that we offer, if you publish your contracts through us, is that when you do, we automatically convert every single or bind every single method in your contract to an HTTP endpoint, which is really neat because now all of a sudden, anyone who's developing on Ethereum, you obviously have some expectation that people are going to be using every single decentralized component that they can, right? So they'll be using, a wallet that hooks up to IPFS for your files and everything else. But ultimately, you need a bridge between, the sort of centralized world that we have today and the decentralized world that all of us hope for. And what we're hoping is that this sort of API endpoint that we offer for contracts enable you to still build something that has that decentralized focus in mind with your smart contract, but lets you build a web app easily while interacting with those contract methods programmatically as you would any sort of web endpoint, which is sort of what this image illustrates. So we do recognize that in a fully decentralized world, everyone would be running an Ethereum node in their pocket. But that isn't the case today, not yet. And it isn't the case that everyone is going to be, getting all of their resources from IPFS or Swarm. There's still this big, widely accepted web out there that you can interact with. And having an API that lets you call into contracts this way enables you to support basically both worlds. And so that's where we kind of place ourselves as a bridge between those two. So if we had to look at things on a sort of decentralization spectrum, over on the left is everything running your own node, running your own infrastructure. And then as you get further to the right, you get to basically the old model or the old way of doing things. And our API services are right in that sweet spot with the big POW block in the middle. Which again we think can be really powerful as you're building services that you want to work not just in that decentralized world but also on the web. Okay, so this is going to be doubly disappointing. So from my experience in watching Ethereum demos, all of them have to be world changing. That's what I've been told. Mine isn't, from what I can tell, but I think it'll give a nice demonstration of what it's like to build something that may have worked in a prior blockchain and try to adapt it for Ethereum. And unfortunately, again, the demo won't be as impressive because I don't think it'll actually work with the DOS going on because our chain isn't quite up to sync at the moment, but we're going to try. So a little bit of background, my first Bitcoin demo, first demo I ever did with any blockchain was what I called BitDuck, which was an ephemeral web app for playing the game Go. And I built it with a library that I built using the Go programming language. Maybe the main reason I wrote the app is because I enjoy wordplay, which is an awful reason to build any product, but it's one that I still engage in. So the way that this worked, for those of you who are familiar with Bitcoin, is you'd have a transaction that was just a multi-sig, pay-to-script hash address, and then embedded in that transaction would be an op return, which is the equivalent of just storing data in Ethereum. And you could effectively have this sort of pairing off of transactions where each player would sign a subsequent move, add their op return, which showed which move they made, and then you'd query that entire address and look through the transaction history and reconstruct the game. So I decided to take that and see what would it be like to do this, but with Ethereum in mind. How would that be different? How would the structure of that application be different? And how could you leverage a service like ours to build something that could be accessible via the web, but also be usable for anyone using Mist or anything else, just interacting directly with the Ethereum blockchain. So this is sort of a more in-depth discussion of sort of the design differences when approaching this. So on the Bitcoin side, as I mentioned, it was a 2-of-2 multisig, but it required interactive participation, and it really wasn't anything more than a toy. So you had to get both parties to supply their signed transactions, at the same time, which was problematic. The games were reconstructed from op returns and transaction history, which again is sort of hackish, and the winning condition required sort of custom interaction between both players. Again, it couldn't be automated. It was kind of a hack. In Ethereum, on the other hand, there's no interactive participation required whatsoever. Games can be created and moved through what I just call a proposal authorized cycle, although I'm open to suggestions about how to do this better once you guys take a look at my Solidity contract. The moves are stored natively in the contract, so there's just an array, a dynamic array, where every move is appended onto it and stored in the contract. And then you can preset the transaction amounts and limit the people that can actually pay into the contract by virtue of what you write in Solidity, which is nice. So I guess all this is to say it was a lot easier to accomplish this using Ethereum than it was when I tried to cobble together something in Bitcoin. I don't know what that says about the broader communities, but I'm not going to speculate. Game at a glance. This is sort of structurally what's going on in this contract, and I'll show you guys, at least conceptually, how you would interact with our APIs on these methods. But within the contract, you have just a constructor. In it, you specify you're the Blackstone player, and you specify the board size and the address of the white player. And then the value that you put into the contract is considered the wager, or half the wager, twice the wager, because of the way that you want to try and incentivize people not to cheat the system or prevent sort of a nothing at stake in the bet. But anyway, what winds up happening is that white address, then the Whitestone address, confirms and then adds an equal wager through a contract method. Then the Blackstone player proposes a move. That transaction is confirmed. The contract state is updated with that proposed move being temporary, and then the Whitestone player authorizes it, and so on and so forth. And then at the end of the game, if it's either the Blackstone or Whitestone's turn, they can propose a winner, and they get 75% of the pot, while the other player gets 25%. Or they can propose a draw, but I just didn't put that here. Does that sort of structurally make sense? Cool. So to paraphrase DJ Shadow, it's always important to understand what the soul looks like. In this case, it'll be the ETH duck soul contract. Cool. So just to give you a run through of sort of how this is structured, you have the address of the Blackstone player, address of the Whitestone player, address of the winner, which could have been done more efficiently, but just put it in there because it was easier. This bool denotes whether the game's been confirmed by the opposing player. This one is a sort of state variable to decide whether it's the Blackstone player's turn. This is basically to lock the contract to prevent another move from being added to the proposal or changed after a move has already been proposed. And then this is just to if it's a draw condition, or if someone proposes a draw. So then this is just a state of the board, struct representing the move, x coordinate, y coordinate, color. This is the dynamic array that stores all the moves, and then this is the proposed move that a player enters. So this is the constructor here, confirm new game. This is actually relatively easy code to read, and I won't go through all of it, but effectively, it's pretty easy to. It does what it says it does. At least I think so. But again, I'm a novice at Solidity, so if you guys could point out any deficiencies in my contract, I'd actually greatly appreciate it. And then some modifiers to prevent certain functions from involving outside parties. So yeah, this is the proposed move function, which winds up storing that sort of temporary proposal variable, the authorized move function, proposed winner, proposed draw, authorized draw, and so on. So that's sort of how the contract is structured. There are a lot of ways that this could be improved, I know, like even adding events, which I just didn't do, but I know that could be a big improvement. And instead of generating a new contract for each person playing a game, turning this into a contract library would also be a big improvement. But just wanted to sort of start with something. I'd really love to do the demo, but it seems like the bros are still coming at us based off the last Geth release. So that I think is a picture of him causing long validation periods for blocks. But yeah, I had a demo that would basically take that game and use local game move logic through this Go library that I built to basically score and update the game board. And then it would use a smart contract address, the address that you wrote, look through those state variables and reconstruct the game just the way that I did with my Bitcoin demo, but doing it directly on the web. So I do have, and I think just to give you a small taste of what it would have looked like. This is just sort of like the little bootstrap initialization. Put the size in, your private key, posing player address, the wager for the game, and then you'd wind up selecting submit, and it would return a smart contract all through BlockCypher, smart contract address, all through BlockCypher's API. You'd wait for that address to confirm, and then there would be a 4x4 grid where you can pick a move. And right now, based off limitations of the API, you'd actually submit the private key to sign the contract method, and then that move would be added. So what I do have is from when we were up in sync, I have a few curl commands that sort of demonstrate what this process would look like and what the returns look like from the BlockCypher API, and I can show you guys that, which I will. Although it's a lot less exciting than seeing a web app and seeing like Mist sort of interact, or in my case MetaMask, like interact with that address and have it still be updated in the web app. Yeah.
Does the BlockCypher API yet have testnet? I mean, that would solve this problem with it.
That would, and actually, so one of the things that, so there are a few other BlockCypher members here I should mention. Brian over there is one of our back-end engineers. Karen is our head of growth. And Brian and I were, and mostly Brian I should say, 90% Brian, was really, we were trying to get a rudimentary version of our testnet up and running even before this presentation was starting, because that would definitely help, and it's one of the things that's on our roadmap to provide to everybody. Because one of the big features that people in the Bitcoin community really loved when they use us is our internal testnet, which doesn't suffer from the same sort of attacks that BTC testnet 3 does. And we're absolutely planning on adding that to Ethereum. And having something like Beth or BETH testnet, that I can tell you personally, having tried to build this myself, that would definitely ease my pain as a burgeoning Ethereum developer to have that sort of consistent testnet. So it's on our radar. It's just not available yet. But yeah, good call. So let me go to just to give you an idea. It's not as fun or visual, but hopefully it'll still demonstrate how easy it is. Is that okay font-wise, or is that good? Okay. So here, because I'm just using these addresses temporarily, I'm just generating 2 new addresses using a simple post command. So it gives us private key, public key, and then the address itself. I'd say don't steal my private keys, but I already suicided these contracts, so feel free to steal them if you like. So this was just to confirm that the black player, the Blackstone player, has a balance, which I sent externally, and so it does. You'll notice that everything's in way, so you're going to be dealing with some big ints, and however you interact with it. And then this is sort of these TX refs are these shortened transaction objects in the address return that tell you a little bit more detail about the particular transactions that lead to that balance. So now that I have, that I know that my Blackstone player has, has some way in there, I want to publish the contract. So I just hit this endpoint, and then just to give you an idea of what that JSON looks like. So I have the full solidity that I've just turned into a single line, and then the parameters for the constructor. So this is the board size right here, 9, and then the Whitestone player's address. Then this is something that we also have on our roadmap to improve. At the moment, in order to publish a contract or interact with any contract methods, you have to include the private key of the external account that's publishing that contract. That is obviously like a general no-go when you're creating prod-ready applications. But if you're already dealing with addresses that you know will have a small amount of balances, this is actually a lot more convenient than having to deal with the signing. But still, we do recognize that it's a weakness, and we have a two-step transaction signing process that we're very likely going to emulate for our contract APIs in Ethereum as well. But yeah, then you put the published name of the contracts that you want to publish with this call. I only have one, but you can have multiple contracts there. The gas limit, which thankfully was right below 1.5 million for me. And then the value that I want to include with that contract being published. So what you get as a return from all this is the solidity that you sent one way, and then the compiled binary as well as the ABI for your contract. Go all the way down here. And then obviously the very important is the address where the contract was created and the transaction hash that created that contract. So now let's say you're the Whitestone player and you want to confirm this game and get this wager going. Well, it's actually pretty easy to do so. So you just include a gas limit, a private key, and then a private key of the Whitestone player, and then the value that has to equal sort of the initial wager, which in this case was 0.25 ETH. So all you do, and this is I still think what's really powerful, is you call the contract API with the contract address, and then just the method name at the end of the URL. So this is confirm new game right here. Confirm new game. And this particular function doesn't actually, or this particular method doesn't have any parameters, but you can add those to the API call as well. And what's also nice is, for constant methods, we don't actually interact with the blockchain, so those are much faster return. So you can check, in this case, confirmed as a public bool in that contract. So you can just, again, add confirmed as a method at the end of it, and then you get in here a results array that includes the results in the order that you'd expect them from the solidity and in the typed correctly. So ditto with the sort of checking the black move.
Could you clarify that a little bit? Like how you guys do that without interacting with the blockchain?
Well, if it's a constant if it's a constant method, so we end up storing the state I think in memory for anything that's published through us, where we have the ABI. And so when this only works when you publish a contract through our API. Otherwise, we don't know what the ABI is, and so we can't do that as easily. Yeah. Cool. Any other questions? I know this is a lot less fun than seeing a Go board changing on the web, but blame the hacker. Yeah, if you want to actually propose a move, that function just requires an XY coordinate because you can determine what the stone, which stone is actually sending that through Solidity. So here you just add this params field, which includes all of your arguments in the method. So in this case, it's just a bunch of uint 8s, so it's just 0, 0, and then boom, you get this result. So you can sort of see as this evolves, and eventually you'll get down to getting, you can get moves, and eventually you get the end state, and the contract self-destructs. So what's pretty cool is, just to show you that I have nothing up my sleeve, can go to Etherscan, and this is the full sort of contract and that full interaction. What happened on Ethereum, and yeah, what's pretty cool is at the end of the day, there are two internal transactions that were at the end of the game, and it was that pot being split 3/4 to one address and 1/4 to the other. High aspirations for this sort of Go game, much like sort of the augurs and the gnosises of the world. I think it'd be pretty cool to start incentivizing, wisdom of the crowds to make games more interesting. So, ideally, sort of my wish list for this is to build it as a way where observers can actually participate by incentivizing individual moves in a game, and then taking a portion of the wager if their player actually winds up winning. I think it'd be a lot of fun. But obviously, wasn't quite ready for this demo, but I hope it'll be ready one day. It'd be a lot of fun. So what's next for BlockCypher's Ethereum support? A lot. We're really big on being sort of the AWS for blockchains. So we really want to provide all sort of API services, or provide a majority of the API services for people that are interested in offloading their infrastructure to a single provider. And Bitcoin has done a pretty good job of covering a lot of what's available, and Ethereum is the next great frontier for us. So for us, that means a lot more endpoints. We currently have webhooks, but we don't have event listeners for native Ethereum events yet. But that's probably coming down the pipeline. The other thing that has been made clear as a result of these various attacks over the last few days is that there's a lot of things that we've done to harden the sort of Bitcoin side of the equation that can be hardened with Ethereum. We have our own sort of custom network code that we built with Bitcoin that we can extend to Ethereum that would make us a lot more robust, and we're planning on adding that soon as well. And lastly, as the gentleman over there was asking about, our own internal ETH compatible testnet is very much on the horizon, and it's coming very, very soon. So that will make sort of the pain points of developing this stuff and interacting with these contract methods a lot easier, and hopefully will enable me to show a more impressive demo in the future. Then the other piece that I think is very important from a security perspective is having a two-step signing process on our contract method API and contract publishing API, because obviously you're not going to want to put a serious amount of money when you're transferring a private key willy-nilly left and right, and we understand that. And the other thing that we're interested in building out is more client-side tooling to help developers that are interested in either engaging in sort of smart contracts that are like templates for stuff that they want to build, where we can simplify that process, or even making it easier to program certain things in Solidity or interact with our APIs. So we've gotten pretty good at that on the Bitcoin side, but there's a lot less to sort of cover on the tooling for Bitcoin, and we want to do a lot more of that for Ethereum. So with that, I believe that sort of wraps it up for me. But are there any lingering questions or comments, feedback? Yeah.
Yeah. So let's say I already have like a tap running using Web3.js.
Mm-hmm.
Could I connect to BlockCypher as a provider using that, or?
We don't have a Web3 compatible API at the moment. Is that something that you as a developer would be interested in seeing sort of direct one-to-one support on?
Yeah, certainly. So I'm just wondering, next year I can make curl plans, but yeah, how would I sort of connect that to like perhaps a client-side JavaScript application?
Yeah, at the moment, it would be more. I guess it would be more about changing your commands to fit the endpoint structure that we have now. That said, there's so. I can't say for certain whether we're going to ever have like one-to-one Web3 compatibility, but we certainly try to be interoperable and enable people to use whatever they want, whatever tooling they want. And I can imagine that we evolve the API responses to more closely emulate what DApp developers would expect. But I don't know if I could say for certain whether we provide that necessarily, but it's something we'd be open to, I think.
Okay. Yeah, it seems like there'd be a fair amount of sort of common code in the application using those we require in terms of like
Sure.
the application go into those HTTP curls. Do you have like plans for that, or is that already existing?
I actually don't know. I can't tell for certain whether we're planning on doing that. I'd have to talk to Matthew and our CTO is not here, and Brian probably. Good question. Cool. Yeah.
Do you see the goal of these APIs just getting feature parity with the Ethereum clients, or do you see it like expanding out to like support IPFS and things like that?
Yes, that's a great question too. So I think we can look at what we did in the Bitcoin space as a guide there, because when we started with Bitcoin, it was literally just about like changing the RPC commands from Bitcoin Core and making them have some sort of semblance or of order to them, and making it easier for developers to interact with them. But after that, one of the biggest successes that we've had with Bitcoin was our confidence factor, which is a service that is not really possible on an individual node basis. To those of you who don't know, the confidence factor is a product on our Bitcoin API that enables developers to get some sort of confidence interval about whether it's likely that a transaction is going to be double spent against. That might be less important in Ethereum with 15-second block confirmation times, but with Bitcoin's 10-minute times, it can make the difference between a reasonable customer, purchasing UX and an unreasonable one. But that's a product that didn't exist anywhere else, and we kind of created it because we were in this perch where we had a really high throughput node that connected to lots of others. And I kind of view that as a blueprint for the kinds of services that we are aiming to provide. We're still sort of new to the Ethereum community, so we're trying to figure out like where the biggest pain points are and where we could add the most value with those sorts of services. I think that was sort of, in the Bitcoin case, we stumbled on that and it became really successful. And I think we would love to provide similar services once we've reached parity with various Ethereum clients. And I just really liked doing that. Yeah. Thanks. Any other questions? Oh, yeah.
On the node of parity,
Yeah.
do you plan on running any parity nodes? Because that might help.
Well, no, that's true. So we're predominantly a Go shop, which is maybe part and parcel. So certain low-level stuff that we have is basically just run from Go Ethereum. I think we've been interested in parity and sort of Rust implementations. One of the biggest sort of low-hanging fruit is that sort of network code that we've really tuned on the Bitcoin side, and we know that there can be huge advantages for us on the Ethereum side by porting that over. So I think that's probably going to be the first thing that we look at. And beyond that, like our Bitcoin implementation is really, really custom, and we might be open to doing another custom Ethereum implementation, which I'm very happy to hear is encouraged in the Ethereum community, unlike some other places. Cool. Any other questions? All right. Thank you.